Hello, this is Dr. Mears, and today we are going to learn about different forms of a quadratic function. There's going to be three different forms, and from these three forms, we're going to learn about various information that they provide. The first form is vertex form. Vertex form is in the form f of x equals a times a quantity x minus h squared plus k, where a cannot be 0. And the reason why a cannot be 0 is because if we substituted a as 0 here, it would completely get rid of this first part of the form, and we'd be left with k, which would just give us a line, and we need a parabola. So a can be any number except for 0. So here's our examples for vertex form, and here's the information that vertex form provides. We have three different equations here. I'm going to go through one by one. The first one here is f of x equals -3 times the quantity x minus 4 squared plus 1. And above here, what I like to do is I like to label my a, my h, and my k, because we're actually going to be pulling those numbers out. So as you can see, a, h, and k will be numbers, and a cannot be 0. All right, so it asks us what is a, so we're just going to look. The number underneath a is -3, and we write that down. Then we're going to pull out h. Now we have to be careful here because in this form, it's x minus h. When we pull the h term out, we actually have to pull the opposite. So I know this is -4, so when you pull it out, it has to be +4. When we get into solving these equations, you are going to see why that is. When we do solve it, we have to set it equal to 0, and we add 4 to both sides. So if you see any type of form where it has this minus and we're pulling out the number, it does have to be opposite. And I wrote that down, use opposite sign. So I did, it was x minus 4, so I pulled out 4. Now k, because this is plus and it is plus here, we can just pull out the number, which is 1. So the only one that you use is going to be this h1. So just please be careful. Okay, so this parabola, it's either going to point upwards like that or point downwards. And how we could tell is we look at the a value. Our a value is -3. If it's negative, it's going to point downwards. So it's going to have this maximum right here. So because it's negative, this one goes down. So it's going to look like this. And so this is actually going to have a maximum. I'm just going to write that there. It's always good to put down some more information. Our axis of symmetry. Remember, our axis of symmetry is that imaginary line that passes through the middle of the parabola right through our vertex. And that's going to be in the form x equals, and then whatever our h term is, I'm going to use the 4. So x equals 4. So that's where that axis of symmetry is. And what is our vertex? Our vertex is going to be h, which is 4, comma, k, which is 1. And so that's why we're pulling these numbers out, because it tells us about the graph. We now know it opens down. It has a maximum. We know where its axis of symmetry is, and we know when its vertex is. So if we actually pull out, I'm using that word a lot, if you pull out your graphing calculator and you put this in, y equals, let's clear out some things here. Just press clear. -3 x minus 4 squared plus 1. Now I use this square button here. I use this square button right here. You can also use the exponent button. That's fine. Just remember to get out of the exponent spot. Okay, so I'm just going to zoom standard. To go to, let me clear that out, -3 x minus 4. I hit the exponent button by accident. There we go. Now we can graph. What we should see is it's thinking. There we go. Here we have opens downward. Here's 1, 2, 3, 4, 1. There's your vertex, imaginary line, x equals 4. So we could tell, we could get information from a graph without actually having a graphing calculator. So let's try these next two. We're going to pull out a, h, and k. A is 2. H, remember, we have to do its opposite. The opposite of plus 3 is negative 3, and then k, remember we can use that sign, so it is minus 6, so we are going to pull out minus 6, so we have negative 6. Okay, so let's look at our a value. It's positive, so it's going to go up, which means it's going to go like this, so we know it's going to have a minimum. Our axis to symmetry is x equals our h, so negative 3, and our vertex is going to be negative 3, comma, negative 6. And even just pulling them out like that, as you can see, I can easily fill everything in. You can go ahead, why don't you try this next one and pause the video, and then come back and see if you got it right. Okay, so we have a is going to be negative 3, h is going to be positive 1, being careful, and k is going to be negative 5. It's going to open down. It's going to have a maximum. Our axis of symmetry is x equals, whoop, not negative. Here's, what are you doing? X equals 1. And then our vertex, 1, negative 5. And so I like vertex form because everything is really right there. There's no additional steps to do, which is what we're going to see in our next form. Our next form is called general form, and that's in the form f of x equals ax squared plus bx plus c. A, again, cannot equal 0. If we substituted it in, anything times 0 is 0, it would cancel this out, and look what we have. We would have a line. We would have mx plus c, so, or bx plus c. So you need the a in there, so it could be any number except for 0. We have 3 examples again, and we're going to pull out information. It's going to be a little bit different. We're going to be able to actually get a y-intercept now, but we're going to still pull out our numbers, and then I'll show you what we're going to do. So here we have A, B, and C. A, B, and C are numbers, so I like to put A, B, and C. The reason why it's general form, because it's an ABC form, easy to remember. So let's pull out our numbers, and notice we have all in the form, they're all positive, so that means we don't have to remember any opposite. Like the vertex form, we just pull out the numbers as we see them. So here A is 2. B is 4, and C, as we see, a minus 1, so it's going to become negative 1. So we just pull them out just like we see them. We're going to do the same thing. A, we're going to look at our A value. It's positive, so we know it's going to go up, and so it's going to have a minimum. Now what we need to do is we need to find the axis of symmetry. We need to find what x equals. And vertex form was a little bit easier. It was right there. Here we have to do some work. What we're going to have to do is we're going to have to do the opposite of b divided by 2a. Notice how I said that. I like to put my negative up next to my b. So I'm going to do the opposite of whatever my b value is divided by 2 times whatever my a value is. So let's do that. The opposite divided by 2 times whatever my a value. Notice how I wrote that in without putting any numbers in yet. I like to set that up because this negative sign might get lost somewhere, and I don't want you to lose it. And the 2 you might forget. So let's, the opposite of b. b is 4, so now it becomes negative 4. And 2 times a is 2. And you can do this in your calculator if you would like to. You can go negative 4 divided by 2 times 2, and we should get, that's not right. Oh, let's go through that really quick. Negative 4 divided by 2 times 2. This is what I did here. And so what the calculator did is it didn't realize that I wanted to multiply. So I wanted to take the negative 4 and divide by this number multiplied here. So in order to do it in the calculator, you would have to do negative 4 divided by and then 2 times 2 to keep the denominator together. And so that gives us a negative 1. This is the correct one. So I'm going to actually show you that here. So negative 4 divided by, I want to multiply this first, 2 times 2, which is positive 4. And then I wanted the calculator to divide. So that's why these are 2 different answers. So if you did it like the first, how I did it here, you're going to get the wrong answer. This is not correct. I'm actually really glad I made that mistake this morning. So You want to keep the denominator together. If you can't remember that, then just do it in 2 steps on your paper. Because if you get this wrong, then everything here is going to be incorrect just because of that one little mistake. So this is a mistake that you don't need to make. So please be careful. Okay, so I'm going to pop over here because axis of symmetry, x equals the value that we received from doing this step. So x equals -1. And it also is the first part of my vertex here. So I'm going to fill that in, x equals -1. So what are we missing? You're right. If this is x, we're missing that y. We don't know what the y part is of the vertex. So how do we find that? We use substitution. So what we're going to do is we're going to take this -1 and we are going to substitute it into this side of the equation. This should feel familiar. This is why we spent our chapter on functions previously. You substituted things in. This is exactly what we're doing. So this should not be new to you. So we're going to do 2 times -1 squared plus 4 times -1 minus 1. And in the previous chapter, I even set the equation up, and in place of the x, I would put parentheses. I'll show you that next if you don't know how to substitute. If you're just watching me for the first time, welcome. So this is going to be f of -1 equals, and if you want to do order of operations, you're more than welcome to. To save time, I am just going to do this in my calculator. Squared plus 4 times -1. Please make sure that you're also noticing how I'm using the negative symbol here, and I'm using my parentheses. Put it in as you see it, and we're going to get -3. So this is the y part of our vertex, -3. And we're going to be, so the vertex is at -1, -3, opening up. We're also going to be able to find the y-intercept. The y-intercept is going to be x equals c, and then we're going to write it in the point 0, c. So where the c is right here, -1, we're going to write it in as 0, -1. So that c part is where it intersects the y-axis. A lot of -1s here, huh? Okay, let's keep going. F of x equals -x squared minus 6x plus 4. Please be careful because this -1 here, that -1 had a space there, and a lot of people forget to put their ones in. So let's pull out a equals -1, b equals -6, a, b, and c. C equals +4. Again, write it like you see it. So we have, let's look at A. A is negative, so that means that we're going to open down. So it's going to open down, and it will have a maximum. Let's find what the x value represents. So we're going to do the opposite of b divided by 2 times. And if you want to put parentheses like this, you can, whatever our a value is. So it's the opposite of -6. So notice that's why I write the negative sign first here, because we are doing the opposite of a negative, which turns it to a positive. And then 2 times -1. Now, notice how I also set my parentheses up. If you do it like this in the calculator, you are going to get the correct answer. I put parentheses around my -1 because I want to tell the calculator to multiply, and I put parentheses around this 2 times -1 because I want the calculator to do that operation first, the denominator first. So let's put it in exactly how we see it here. There we go, -6 divided by 2 times -1 with parentheses and everything, and I get -3. You could do it in 2 steps, absolutely fine. Just be careful of your negative signs, everybody. All right, so this is -3, lots of -3s, and that x value is also part of the vertex. Okay, next we have to substitute it in. So this is what I mean by parentheses. So if you've never substituted, there's the bell. If you never substituted anything before, what I do is I like to physically take my x away and in place put parentheses. So this was a -x squared, so instead of that x, I put parentheses. This was a -6 times x. Instead of the x, I put parentheses, because then I could put the number I want into the parentheses, and that's what's called substitution. And it makes it really nice because then I can just go to my calculator and see what it calculates out to be. Making sure you're using your parentheses. I want this negative squared here. Okay, double checking, negative 3 squared minus 6 times negative 3 plus 4, and we are going to come out with 13. That is my y value of my vertex. So the maximum here is negative 313. And our intercepts, y is c, so we're going to go to 4, and we're going to write it as the point 0, 4. Okay, so a lot of information here. I know where it crosses the y-axis. I know where the maximum is. I know that imaginary line crosses at x equals negative 3. All right, lastly for this one, f of x equals x squared plus 7x plus 1. Please make sure there's no number in front. The ones like to hide, so I like to put my ones in because I'm going to try to find my a, b, and c. I like to write a, b, and c. So a equals 1, b equals 7, c also equals 1. Putting the numbers in just like you see them. Let's find out if it opens up or down. A is positive, so we're going to be opening up, which means it's going to have a minimum. We're going to find the x value, so x equals here. We're going to do the opposite of b, so opposite of b divided by 2 times our a value. So let's see what b is, the opposite of 7, so negative 7, divided by 2 times 1. We're going to come out with, notice my nice parentheses, negative 3.5. Oh, a decimal. Negative 7 divided by 2 times 1 is 2, negative 3.5. Now let's substitute it in. F of x equals, and again, I'm just going to use this little method that I taught you of substituting it in, where I take out my x and I input my set of parentheses. Where those parentheses are, I am going to input my negative 3.5. Please be careful. It is important to use those parentheses because I want my negative 3.5 squared. Then I'm going to put it in my calculator just like I see it. Double checking it, negative 3.5 squared in parentheses plus 7 times negative 3.5 plus 1. And I'm going to get negative 11.25. So that is my x value, negative 11.25. Also my x value here. Nope, not my x value. What are you doing? I forgot to go all the way over from negative 3.5. So be careful, everybody, when you're filling this in. Negative 3.5, it's my y value of a negative 11.25. So my axis of symmetry is x equals negative 3.5, and my vertex is negative 3.5, comma 11.25, which is what we just found. I can also find my y-intercept, which is going to be 0c, so 0, 1. And this has been general form. Our last form, which is going to take us to intercept form. An intercept form is exactly what it sounds like, intercepts. And it's the intercepts of the x-axis. So it's going to be crossing the x-axis somewhere. And that's what we're going to be able to find out right now. So our intercept form is in the form f of x equals a times the quantity x minus p times the quantity x minus q. Again, a cannot be 0 because it would absolutely cancel everything out. We would have nothing on the side except for the number 0. Let's look at what information this form provides us. Again, a, p, and q are going to be numbers. And our first one, first of 3, we have f of x equals 3 times the quantity x minus 4 times the quantity x minus 2. So we have a, p, and q. Now I'm hoping that you remember and that you're going, oh no, I'm going to have to remember the opposite. Yes, because this is minus, x minus p. And because this is minus, x minus q, when we pull the numbers out, they're going to have to be the opposite of the sign that you see in the problem. A is absolutely fine. A is 3. But when we pull p out, it's x minus 4. You have got to remember that when you pull it out, it's going to be a positive 4. Here, it's x minus 2. When you pull q out, it's going to have to go from x minus 2 to a positive 2. You have to remember P and Q get opposite signs. It's all because of this minus here. Okay, so how do we find the axis of symmetry? The axis of symmetry is going to come from P plus Q divided by 2. I should have put parentheses around this because that's what you need to do in the calculator. You need to do the numerator first here. It was the denominator last time. That's what happens in math. It always switches. So in order to find my axis of symmetry, I'm going to take P and Q, 4 plus 2, and cut them in half. And that makes sense because if we have these 2 points right here, we're just trying to find the middle. Adding it up and dividing by 2, there's 2 of them, just finding the middle. So when we add these up, 4 plus 2 and divide by 2 in the calculator, this is where your parentheses need to come in because you have to add them first. We're going to come out with 3 equals 3. X equals 3. And yes, that is the first part of our vertex. This is X and this is Y. So we need to find the Y value. So yes, you substitute and solve. So let's do that. We're going to take f of x equals 3 times x minus 4 times x minus 2. Now, I just put a space there. You really don't need parentheses. If you like to do the parentheses, you can, but because it's first, the calculator will always recognize any type of negatives. So remember, I use parentheses for negatives and for multiplication. So let's see what this looks like. So I'm going to substitute 3 in, substitute 3, and substitute 3. You could put parentheses around that, absolutely fine. F of 3 equals, so in the calculator, just as you see it, you could do order of operations, absolutely fine. We get negative 3. Negative 3, and that is the vertex, the Y value, which is negative 3. One last one, does it open up or down? Again, you still look at the same value. This is always consistent amongst all the 3 forms, and that's the A value. It's positive, so it's going to go up. So we have a minimum at 3, negative 3, with an axis of symmetry of x equals 3. Right, let's try these next 2. We have A, we have B, and we have C. Nope. A, P, and Q. See how you can get confused with these? Got to keep them straight. Hopefully you're taking good notes. A, P, and Q. Okay, A's symbol or sign stays the same. A equals negative 2 because the function reads f of x equals negative 2 times the quantity x plus 3 times the quantity x plus 1. And A is negative 2. Remember, P and Q, you have to use your opposites because of this minus right here. So here we have x plus 3, so yes, P is going to be negative 3. Here you have x plus Q, Q is going to be a negative 1, so they're opposite. In order to find our axis of symmetry, x value, we're going to do negative 3 plus negative 1, P plus Q all over 2, remembering the parentheses and the numerator, because you want to do the numerator together. Negative 1 divided by 2, you want to do the numerator first. So we're going to come out with a negative 2. Negative 2, that's also the vertex x. Let's find y by substituting it in. F of x equals negative 2 times negative 2 plus 3 times negative 2 plus 1. Now, if you want to put parentheses because you feel comfortable with putting parentheses all the time with negatives, because I've been training you to do that, feel free to. Again, it's not needed here, so you could do this absolutely fine. It won't hurt a thing. Because it comes first in the set of parentheses, you don't really need it. But either way works, negative 2. Okay. So f of negative 2 equals, and you know what? I'll show you with the set of parentheses what that would look like, those double sets. Plus 3 times negative 2 plus 1. So double checking, negative 2 times the quantity, negative 2 plus 3 times the quantity, negative 2 plus 1. Enter, and we're going to come out, ooh, that's a nice number, positive 2. Positive 2 and positive 2. And does it open up or down? Let's look at A. A is negative, so it's going to open down. So we know that we're going to have a maximum at negative 2, 2, and an axis of symmetry of x equals negative 2, that imaginary line. A lot of 2's here, a lot of 3's here. Look at that. I don't know if I worked that out or what, but I made these up, so that's really weird how they're coming up. All right, f of x equals the quantity x plus 3 times the quantity x minus 6. Now we have an a, we have a p, and we have a q. And again, we do have an a. Please write your ones in because those ones like to hide. A sign stays the same, a equals 1. P and Q get opposite, so here P is x plus, so we're going to take out that negative. Here x minus, so we're going to take out that positive 6. So A is 1, P is negative 3, and Q is positive 6. Let's find our axis of symmetry. We have to add P and Q together and divide by 2, so negative 3 plus 6, negative 3. Negative 3 plus 6 divided by 2, remembering those parentheses, we get 1.5. I'm always ending with decimals on my last number. That's always fun. All right, let's substitute it in. It's going to be f of 1.5 equals 1.5 plus 3 and 1.5 minus 6. In the calculator, remembering those set of parentheses, because remember, these are times, so that's why we're using these parentheses here. 1.5 plus 3 times 1.5 minus 6. Ooh, negative 20.25. Negative 20.25. I wonder if that's a max or a min. That's really low. That's a negative. All right, so let's fill this in. X equals 1.5, 1.5, comma, negative 20.25. And let's see if it opens up or down. A is positive, so it's going to open up. So that's way down on that y-axis. It's going to have a minimum at positive 1.5, negative 20.25, and an axis of symmetry, imaginary line crossing at 1.5. So this has been the three forms of a quadratic function. We had vertex form, I think the easiest one. We have general form, and then we have intercept form. Remembering some things like P and Q get opposite signs. General form, A, B, and C are absolutely fine. And then vertex form, your H has to use the opposite sign. Hopefully this helps. Good luck. Thank you.